Hi everyone, and welcome back to Maths and Physics. So this is video number 2 out of 8. Very important in this trigonometry lesson. We're looking at reduction and the cast rule, and why reduction exists and how we use it. Right? So reduction in trigonometry, short, is a process of rewriting trig ratios of an angle outside the first quadrant. So there's my first quadrant. So angles in the second, third and fourth quadrants, that's larger than 90 degrees. You see, I'm going bigger than 90 as an equivalent trig ratio of an acute reference angle. So we want to go from here to there while adjusting the sign according to the quadrant in which the angle lies. So then, in short, you see, if I said to you sine 135 is an obtuse angle. It's bigger than 90. Right, so I can reduce this to acute angle by knowing that 180 minus 45 would give me 135. There's my acute angle. You follow? So there I'm reducing. So therefore in quadrant 2, we would say 180 minus the theta, minus the reference angle. Go third quadrant, I have tan 240. So 240 lies between 180 and 270. So I should know 180 plus 60 would give me 240. Therefore, in that quadrant, the reduction formula I would use would be 180 plus theta, because theta there would become the acute reference angle. If we say cos 300, 300 lies between 270 and 0. So to get to 300, I'm going to say 360 minus 60. So therefore, quadrant 3, reduction formula we use, 360 degrees minus theta. So in simpler terms, reductions allows us to express trig functions of larger obtuse angles, 135, 240, 300, in terms of the same functions of smaller acute angles. Right, so now I'm just going to go a little bit more in detail, explain to you the cast rule. So stay with me. So according to cast rule, right, we draw a Cartesian plane, x positive, y positive, x negative, y negative. This here is referred to as quadrant 1. They have quadrant 2, quadrant 3, and quadrant 4. Now we take in account, we should know sine theta. What we've done in grade 10 is y over r, cos theta is x over r, and tan theta is y over x. So in the first quadrant, I'm substituting a positive y and a positive x. So therefore, sine there, positive over positive, cos positive over positive, tan positive over positive. So whatever answers we have for sine, cos, and tan in the first quadrant, any angle between 0 and 90 will give me a positive answer. So yeah, sine, cos, and tan are all considered to be positive. If I go to quadrant 2, I have y is positive, but x is negative. So you see there's sine, positive y over positive r. So sine is positive, but if I say cos theta, negative x over r, so I'm going to get cos to be negative there, and tan, positive y divided by negative x gives me a negative. So in the second quadrant, as you can see, only sine is considered to be positive. If I go to quadrant 3, I have negative x and negative y. So sine there, negative divided by positive becomes negative. Cos there, negative divided by positive becomes negative. But tan theta, negative y divided by negative x there gives me tan as positive. Therefore, in this quadrant, only tan is considered positive. All right. If we come to the last quadrant here, x is positive, but y is negative. So there we have negative y divided by positive r, which makes sine negative in quadrant 4. For cos theta, I have positive x over positive r. R is always positive, so therefore cos is positive there. For tan, negative y divided by positive x makes tan negative. So therefore cos is positive. So in short, all trig functions are positive here. Sine is positive here. Tan is positive there. Cos is positive. Right, if we just take the first letter from each word, C-A-S-T, they form the word cast. Therefore, that is referred to as the cast rule. So we need to understand in quadrant 1, all is positive. Quadrant 2, sine is positive. 3, tan is positive. And cos is positive. As far as my reduction formula is concerned, for now, quadrant 2, 180 minus theta. Tan, 180 plus in the third. And 360 minus theta. Alright. Now, reduction in the first quadrant, say, so if I say sine theta, it stays sine theta. Cos theta, stay cos theta. Tan theta would stay tan theta because that's first quadrant. If I'm working in the second quadrant, remember only sine is positive. So if I give you sine 180 minus theta, we need to know that second quadrant. The second quadrant sine is positive, so it becomes sine theta. So I'm reducing this angle to a acute angle. Remember the theta here represents an angle that's less than 90 degrees. So sine theta. So cos 180 minus theta, I'm going to reduce to theta. But this is second quadrant and cos is negative, so it becomes negative cos theta. And when I say tan 180 minus theta, second quadrant tan is negative, that becomes negative tan theta. So you see each time I've reduced to the acute angle. So I'm taking angle bigger than 90 and I'm making it less than 90 degrees. In the third quadrant, only tan is positive. So third quadrant is 180 plus theta. Right, so in third quadrant, sine is negative. So this becomes negative sine theta. Cos 180 plus theta becomes negative cos theta because in the third quadrant, only tan is positive. But tan 180 plus theta then becomes tan theta. The fourth quadrant, only cos is positive. So if I write 360 minus theta, I'm in the fourth quadrant. In the fourth quadrant, sine is negative, so that becomes negative sine theta. Cos 360 minus theta in the fourth quadrant, cos becomes positive. And tan there is negative in the fourth quadrant, so tan 360 minus theta becomes negative tan theta. So this is basic reduction with reduction formula, but we will do it more in detail in the next video. Alright, God bless. Bye.